Okay, now this is a drought map of May 21st, 2013. And you can see here, the black line, the tornado that went through Moore, Oklahoma. And there was two tornadoes. And they both tracked just a few miles, no, maybe 40 miles apart. But you can see why. Take a good look at that drought map. You can see it's a severely drought-stricken area. And not only that, it's associated with grain. Grain has a large amount of static electricity in it when it dries out and blows in the wind. Now, granted, this is 2010, but this is where the main grain is growing as far as winter wheat. Anyhow, you can see the similarity where the grain is in respect to where the actual tornado touched down and moved across Oklahoma. Next, we're going to look at tornadoes. Now, in April 17, 2011, the ones that swept across the United States all in one day. And there was another remarkable similarity here. And the important thing to look at is you see right here on the map where these tornadoes actually start here and start here on that day. Now we're going to take a look at a grain map. Now granted, this is 2007, so the dates are kind of off, but in general that's where we're growing our grains, is where you see the green right here and here. Now what I want you to look at, I'm using PowerPoint, so you have to keep in mind, you got to keep an eye on where these tornadoes are starting here and starting here and moving across the country, and even these up here a little bit too. Now these maps don't match exactly. They're pretty close, but if I could find more current maps of grain in respect to the size here of the maps, but I'm going to try and lay this on here as best I can, and there we go. Now you can see the similarity to where tornadoes are actually spawning, beginning. Now I can't use my cursor. I'm holding it one map on top of the other, so I'm unable to show you again what I was talking about. But you can go back over this tape and you can look at it again, and you'll see where the tornadoes are actually starting in respect to where grain is growing. Next, we're on April 19, 2011. Drought map. Now I'm going to show you with something that's more current, as far as the one we saw before was green, but it was about 3 or 4 years different. But this is the same year. This was April 19th for the drought map, and this is April 17th, both on the same year. Now I'm going to lay this map on top of the other one again. I'm using PowerPoint here, so I can't show you, but the point I'm trying to make is see where they start right here and right here. It's really important to see that, and then you can just go over the tape again or the movie again and see. Now I'm going to lay this map on here pretty close to where it would be, as far as, they're not exact, but look, you see the similarity where tornadoes are actually starting in drought-stricken areas, and same with they're in drought-stricken areas. You see the similarity of where it is. Now if I was to move a map up a little bit, you could see, okay, yeah, they're all pretty much matching to where the droughts are. And this is true with hurricanes as well. You'll see on my website. There is a solution, so check it out and see what I've come up with, but you'll be absolutely amazed, and it's really rather simple. Once you understand how static electricity works and hydrogen bubbles work together, how it keeps our planet in perfect harmony. Everything naturally works together. It revolves around sunspots and static electricity and hydrogen bubbles. And like I mentioned before, there is a solution. Please check out my website.